3. Geography.
I'm sure many of you have experienced jet lag. You know, that tired, off feeling you get after traveling across time zones. Today we're going to look a little more closely at time zones. You all know from the readings and our previous lectures about the lines of latitude and longitude, and how they help us locate a given location on a map. Just to review, we've got the equator at 0 degrees latitude. Now, how does the equator divide the Earth again? Is it north-south or east-west?
The equator, it divides the Earth into northern and southern hemispheres.
Right you are. So, all of the lines of latitude run parallel to the equator all the way up or down to each of the poles. The equator is at 0 degrees and the poles are located at 90 degrees, north and south. Then, there are the lines of longitude. And the big one is the prime meridian. It runs from the North Pole through Greenwich, England, to the South Pole and is designated as 0 degrees. On the other side, it goes back up to the North Pole at 180 degrees. Each line of longitude measures the angle from the prime meridian going east or west to 180 degrees. So, for example, let's take a point on the map. I don't know, how about New York City? New York City lies at 41 degrees north latitude and 74 degrees west longitude. But lines of latitude and longitude have more uses than just finding places on maps. Who can tell me another use?
Well, they act as borders sometimes, right?
Good point. Can you give us an example?
Well, most of the border between Canada and the U.S. follows the 49th parallel, right? That's the latitude line of 49 degrees north. And isn't the 38th parallel the border between North and South Korea?
Excellent. Those are some good examples of another way in which people use lines of latitude or longitude. There's another important use, though. Remember I talked about jet lag and time zones? Let's look more at that. Consider this. One day involves one revolution of the Earth on its axis or pole, right? So, one revolution is, naturally, 360 degrees. Okay, and a day is 24 hours. So we can divide 360 by 24 to discover that the Earth spins at a rate of 15 degrees per hour. How is this useful? Time zones, of course. Every 15 degrees of longitude represents a 1-hour time zone, more or less. Of course, this isn't exact. If you happen to live in a place with a time zone line running through it, you wouldn't want one side of town being in one time zone while you were in the other. Nonetheless, the lines of latitude give us a pretty good idea of how the time zones break down. This is how it works. When the sun is directly over a line of longitude, it is noon. East of this line, it is afternoon. West, it's morning. So, for example, if the sun is directly over Thailand, it is noon there. Go about 15 degrees east to the Philippines, and it's 1 o'clock in the afternoon. Go west about 15 degrees from Thailand to Sri Lanka, and it's 11 a.m. So, let's say we're in Greenwich, England, and we want to call New York. Remember, Greenwich is at 0 degrees longitude and New York is 74 degrees west longitude. So here in Greenwich, it's 7 in the morning. So, what time is it in New York? Just divide 74 degrees by 15. We divide by 15, remember, because that's how fast the Earth spins, 15 degrees per hour. Okay, so 74 divided by 15 is just about 5. So, we're going 5 time zones west of Greenwich, which means we're going 5 hours back. 7 minus 5 is 2, so it's 2 in the morning in New York. Probably not a good time to call. Okay, just to reiterate, time zones are calculated based on the lines of longitude and the spin of the Earth. After doing the math work, we can see that 1 hour of time is the equivalent of 15 degrees traveled by the Earth. You can use this 15 degrees figure to calculate the time difference between two places, which can help you predict how bad your jet lag is going to be on a long trip.
Number 1. With which category are these things associated? Number 2. What aspect of lines of longitude does the professor mainly discuss? Number 3. According to the professor, how many degrees does the Earth spin in 1 hour? Number 4. What does the professor imply when he says this?
If you happen to live in a place with a time zone line running through it, you wouldn't want one side of town being in one time zone while you were in the other.